Okay, so we're going to do another example, and this one we're going to look at finding the magnitude of a field in a given point. So we've done chart the forces between two charged particles, and we've looked at the field around things, the force that a field exerts around things. Now we're going to look without those test particles at the magnitude of the field. And so our first problem says, our example problem says, what is the magnitude and direction of the field midway between 2 point charges? They give us a negative 10 microcoulomb and a positive 3 microcoulomb source charges, which are 6 centimeters apart. So let's draw our thing, and they don't give us any clear indication which is which, so I'm just going to make it this way. Again, our diagram is going to determine what our setup is. So if there was a difference on an assessment or something, I'll look for your diagram to tell me how you set it up. So this is how we're going to set it up. This is 10 microcoulombs. And remember, the micro, you've got to know your prefixes, right? Micro is to the negative 6. So we won't give you those on the test. You're expected to know them. So we're going to use given, find, formula, and work answer, just like we normally do. Showing our work, we're going to start with our givens here. So our given is Q1 is negative 10 times 10 to the negative 6 coulombs, and Q2 is positive 3 times 10 to the negative 6 coulombs. All right, and then R is not 6 centimeters. They're saying, what is the magnitude of the field right there? What is E at that point? Right here. What is E there? So R is actually 3 centimeters in both cases. So 3 centimeters, or 3 times 10 to the negative 2. And I've used this shortcut before with things where you just kind of put that prefix in. Meters. Okay, got to have the right units here. All right, and so let's see, what else do we need? Well, they ask us to find the net electric field. And the formula we're going to use is that one that you should be able to derive, and that is E equals K Q over R squared. And we're just going to add them up. We're going to find the field at this point. We're going to find the field here from this charge. We're going to find the field here from this charge, and we're going to add them together. And in order to do that, we need to know which direction it is. So remember, the direction of the field is determined by the direction a positive test charge will accelerate when we put it there. So if I am looking at this one, this 3 microcoulomb charge, and I put a positive test charge here, this 3 microcoulomb is going to make it accelerate to the left. If I put my positive test charge here and I look at the field created by the 10 microcoulomb charge, at that point the field is also going to point left. So they're both going to add together, and the net field is going to be left or west or negative in convention. Okay, so let's do our work. So my net electric field, net, is equal to K Q1 R squared plus K Q2 R squared. And now I can just plug in. My net electric field is equal to, K, what is K? Well, K was 9 times 10 to the 9th. Or 8.99 times 10 to the 9th, use whatever constant is given to you. So I have 9 times 10 to the 9th times 10, remember, do not stick those signs in there, times 10 to the negative 6th all over 3 squared. Also, please don't forget to square those. That's really important. Plus 9 times 10 to the 9th times 3 times 10 to the negative 6th all over 3 squared. So my net electric field, I'll give you a second to catch up, put that in your calculator, check your work. And you should have gotten 1,300 newtons per coulomb. I will remind you that anything magnitude of 1,000 or larger or 1,000th or smaller needs to be written in scientific notation or with the appropriate metric prefix. So this is going to be 1.3 times 10 to the 3 newtons per coulomb. And that's west is the direction our field is. Okay, so that is your next example. Go ahead and get started on those problems. I'll put that up again for you. So you're working in your Giancoli textbook, and page 466, problems 23 through 28, numbers 31 and 32. All right, good luck.